what we've done in our research is focus on materials, right? So safety is obviously a huge concern, the properties and materials properties that you have to be able to develop for materials, especially new materials that haven't had rigorous testing over, decades basically of use. You have to really make sure that you're honing in on the right materials properties. And so what we've done is a lot of work to figure out how to make these new materials, how to make them, potentially with the future in mind. So, keeping things like sustainability in mind. So where do you derive the materials from? What do you do with them after they're done? We've done some work on chemical recycling of different high performance polymers, which is an interesting concept because, we've always thought of like, if you're up in space and something breaks and you need to like remake it, how would you do that? So can you devise ways to take it apart and then put it back together again and create a new part, for example? So that's been a lot of the focus of our research in sort of the materials, polymer and chemistry space. So we use simulation a lot and modeling a lot. In trying to find new materials, thinking about chemical pathways that explain the materials that we do make. So at IBM, we use a lot of, I would say, classical computational methods to be able to do that. So chemical modeling of reactions, different types of modeling for larger materials, coarse grain modeling, things of that nature. Obviously, that requires a strong background in understanding computer science and being able to code. And then we're taking it one step forward. So my new job is actually working in quantum computing. And so we're starting to develop out the tools, quantum computing being one of them, to be able to perform a whole new series of new calculations for physical systems, chemistry, materials, you name it. So we've put a lot of focus into that. And I think it guides a lot of the different types of research that we do. Absolutely. Yeah. So what we're looking at are structural materials with, high performance attributes, right? So lightweight, strong materials. You can think about these being useful in a number of different industries, including automotive, certainly aerospace, but they can be used for anything that you basically need that kind of strength and lightweight kind of nature of it. As well as meeting certain safety standards, right? So yes, things that you might touch and interact with on a daily basis could be even the same materials or a slightly different form of them. So the teams that do the simulation work, strong skills in mathematics is clear. If you have a background in chemistry or physics, that is also extremely helpful to be able to apply certain algorithms to applications of interest, such as materials development, for example. Certainly, we have a part of what we do that is like AI machine learning. So that gets integrated as well with some of the work that we do. In terms of the actual like in the lab kind of development, chemistry is a really important skill to come in with. Polymer science also as well. So it kind of, as you can see, it's very multidisciplinary, right? It runs a full gamut of different skills. Anytime you bring together diverse teams, right, that is really a way to spark creativity, because as we're forcing engineers to speak with chemists and physicists, what oftentimes happens is, as you're explaining something that might be super fundamental, and maybe during your PhD you just take it for granted that everyone else knows what you're talking about, when you have to distill it down to that kind of granularity, oftentimes what happens is it triggers a spark in someone else and they go, oh, like, that's a connection I can make here. And so the creativity and innovation really rolls out of that. So whenever I staff any team, what I'm looking at and trying to do is create a very diverse team in terms of perspective and demographics, so that we can make a platform basically for people to be able to have creative thought. So I think, you know, at the time that I was getting my PhD in chemistry, it was like only 20% women, even though the class started out around 50-50. There was a lot of attrition of the women in particular, that group, as time went on. I think that for me, it was definitely about finding senior graduate students or people that I could look forward to in my career. I continue to do that even today. I did something that's called an executive assistant role for a woman who was working in IBM Research. She was our COO of IBM Research. And so I took that opportunity to spend a year basically shadowing her and learning from her. So certainly, you know, finding people that have shared experiences across all diverse backgrounds, you know, men and women, you know, everyone can help you in your career, and finding people that you can really learn from and that resonate with you. So once you get to a certain point, pay it forward, you know, get that next generation up and coming and help to support each other as they navigate some really challenging, you know, at times in education and early career days, right? They're very uncertain, new experiences. And so I think the more we can support each other, the better that representation will become.